Hello my dear students, I am happy to meet you again. I am Mr. Abdel with you. Today inshallah we are going to study determinants and the inverse or multiplicative inverse of the determinants of matrices. Let's start with determinants now. We have a triangular determinant. What is a triangular determinant? Let the matrix A be 10, 0, 2, and 1. Look carefully for the 0 here. When the 0 here, this matrix is the order 2 by 2. So, when 0 here, it's a triangular matrix. So, if you would like to find the determinant of this matrix, now we have 10, 0, 2, and 1. So the answer directly will be the multiplicative or multiplying the principal diagonal, which is 10 times 1 equals 10. That's why, because 10 times 1 equals 10, minus 0 times 2 equals 0, so it's 10. So if we have 0 here, we call this matrix triangular, and we multiply the elements or the numbers of the principal diagonal only. And if we have another matrix like that, this matrix 2, 5, okay, 2, 5, 0, and 3. If we have a matrix like that, and look carefully to this 0, okay, if we have 0 here in this corner, so if we want to calculate its determinant, 2, 5, 0, and 3, then we will concern only with the multiplication of the elements of the principal diagonal. So we will multiply 2 by 3 will be equal 6, because if you would like to find it as the last time, we multiply 2 by 3 minus 5 times 0, so the answer will be 6. Okay, so concentrate again, my dear students. If we have 2 by 2 matrix and we have 0 here, okay, or 0 here, we will call it triangular matrix determinant or triangular matrix, and we solve it when we find the determinant by multiplying the principal diagonal only. So it's triangular matrix here and triangular matrix here, and its determinant, its result equal the time of its principal diagonal. Okay, again, if we have a matrix C like that, 3 by 3 determinant or 3 by 3 matrix, and we have its elements 1, 2, 3, 0, 5, 6, 0, 0, 3. Look carefully at this. We have here these zeros as a triangular, so we call it a triangular matrix. And if we want to find the determinant 1, 2, 3, 0, 5, and 6, 0, 0, and 3, so we will concern only about the multiplication of the elements or the numbers of the principal diagonal. So the answer will be 1 times 5 times 3 equals 15. Okay, and if we have another matrix like D, like that, and we have here 0, 0, 2, 0, 1, negative 3, 9, 3, negative 4. Okay, and we have here a triangular matrix because we have here 0, 0, 0, like a triangle, the right up, okay, or here the left down. These are two matrices, we call them triangular matrices. And if we want to find the determinant of this matrix, 2, 0, 0, negative 3, 1 and 0, 9, 3 and negative 4, we will calculate only the multiplication of the diagonal principle like that. We have 2 times 1 times negative 4. The final answer will be negative 8. So if we have a triangular matrix, when we find the determinant, we will multiply only the principal diagonal. Okay. My dear students, look carefully for the next method of determinants. We will use determinants to calculate or to find solution set of two equations of two variables. Okay, there are many methods to find the solution of two equations, but one of important of them is to use determinants. Solving a system of equations of linear ones, really linear. We have here ax plus by equals m and cx plus dy equals n. We have two equations here, and look carefully to its arrangement. Here a number multiplied by x plus or minus a number multiplied by y and equal the absolute term, which is the real number. And here we have cx, a number multiplied x plus another number multiplied y equals the absolute term, which is n. So concentrate to arrange them like that: x, y equal number, x, y equal number. Okay, we will find a matrix of these two equations. We will put the number here, a, and put b here, c here, and d also here. So we have a matrix of these coefficients of x and y of these two equations, and we will have the determinant a for them. This determinant has a, b, c, d, and to find or calculate this determinant, of course, we will multiply a times d minus d times c to find the result of the determinant. Okay, and this we will call it a delta. Okay, so delta equal the value of this determinant of this matrix. We will find something called delta x. What is delta x? Delta x is determinant. A and c here is the coefficients of x. We will replace them by the two numbers m and n, and put b and d as them as it is, and we will find delta x: m times d, md, minus d times n, dn. Okay, also we must find delta y. What is delta y? It's a determinant here like that, and we have here y coefficients here in this determinant. We will replace them by m and n, but a and c as it is, and we will find the determinant like that, an minus mc. And after that we will find x by dividing delta x over delta. Delta x is the value of this number over delta, which is the value of this number, to find x. To find y also, we will have delta y over delta. So the solution set will be ordered pair x and y, which will result from delta x over delta and delta y over delta. Okay, my dear students, we have here now the solution of two equations of first degree, but it's 2 by 2 order of matrix and 2 by 2 the order of determinant. So we will concentrate about example, about numbers. It will be better for you for understanding. So concentrate with me. We have an example here. If we 6x equal 5y minus 23, it's an equation, and the other equation is 3x plus 3y equals 16, and we want to use determinants, or we call it Cramer's rules. Cramer's rule. Cramer is a scientist of mathematics that invent this method to solve the two equations. So first we'll find the matrix A. What is the matrix A? Look carefully at this. We have here 6x equal 5y. It can't work like this. We have to 6x and transfer 5y to be minus 5y, as we agree, equal negative 23. And this one, 3x plus 3y equals 16, as it is. So we will concern with this equation and this equation also. Okay, we have here 6 and negative 5 are the coefficient of x and y. Put here 6 and negative 5. And put 3 and 3, the coefficient of x and y. Then we will find out its determinant. We call it delta, as we said. The delta is the determinant of A, which is 6 and negative 5, 3 and 3. And we will calculate it. 6 times 3 minus negative 5 times 3. And the answer will be 33. So we have here delta equals 33. Concentrate with delta because we will need it. We have also something we call it delta x. Delta x will be negative 5 and 3 as it is, but the coefficient of x, we will replace them by the two absolute numbers, negative 23 and 16. And we will calculate the delta x here. Delta x will be negative 23 times 3 minus, like that, minus 16 times negative 5. And we know that we can calculate this delta x will be equal 11. So we have delta x equal 11. Also, we must calculate something we call it delta y. What's delta y? Here is delta. Here is the coefficient of x. like each of them, 6 and 3. But negative 5 and 3, we will replace them with negative 23 and 16, which is m and n. And we multiply 6 by 16 minus negative 23 times 3, and delta y will be 165. Okay, we have here delta equals 33, delta x equal 11, and delta y equal 165. To find x, we must divide delta x, which is 11, divided by delta, which is 33. And the answer, of course, will be 1 over 3. And to find y, or calculate y, we will divide the delta y, which is 165, over delta, which is 33. And the answer will be 5. So we have now x equal 1 over 3 and y equals 5. So solution set of these two equations will be ordered pair 1 over 3 and 5. And if we substitute by x 1 over 3 and y 5 here in the first equation, we will find that the left hand side equal negative 23. And if we substitute by 1 over 3 for x and 5 for y here in the second equation, will be left hand side equal right hand side, which is 16. And of course, my dear students, of course, we will have 3 order determinant, because we have also an equation. These 3 equations. The 3 equations, of course, will be x, y, and z. X, y, and z, there are 3 unknowns or 3 variables. We will concentrate about these 3 variables to find them by using Cramer's rule. Okay, let's concentrate here. If we have an equation like that, ax plus by plus cz equals m, and because we will have 3 equations, we'll call it a1, b1, c1, and also we will have another equation with this, which is a2x plus b2y plus c2z equals n, and the third equation will be a3x plus b3y plus c3z equals k. So we have here 3 equations and 3 unknowns. The 3 unknowns is x, y, and z. And we will make a matrix like that. We call it capital A. This matrix will have A1, B1, C1, the coefficients of x, y, and z, and A2, B2, C2, which are the coefficient of x, y, z of the second equation. And also we will have A3, B3, C3, the coefficients of the third equation of x and y and z. And also we will have delta. This delta calls the determinant of the matrix A. This determinant will be A1, B1, C1, A2, B2, C2, A3, B3, and C3. And we will find the answer of delta, or the result of delta. We must find also delta x. Delta x is a determinant of third order also, but we will replace the coefficient of x here by m, n, and k. So we write m, n, and k here. Then we will write the remainder of this determinant as it is: b1 c1, b2 c2, b3 c3, and we must find delta y. Delta y, of course, it will be a 3-order determinant, and we will replace the coefficients of y by m, n, and k. M, n, and k, and the remainder will be as them: a1, e2, a3, here c1, c2, c3. And we must also calculate delta z. Delta z is 3-ordered determinant also, but we will replace the z part or z coefficients by m, n, and k. So we put here m, n, and k, which are the absolute terms of the equations of the right hand side numbers, and the remainder will be as it is. We have a1, a2, and a3 here, b1, b2, and b3. Now we have delta x, delta y, and delta z. To find x, we have to calculate delta x divided by delta. To find y, we calculate delta y over delta. To find z, we calculate delta z over delta. And the final answer will be the solution set, which is a set here, triple ordered, which is x, y, and z. Okay, we have here the method, and we will go. Okay, my dear students, we have here 3-order determinants, and 3-order determinants we will solve it by using determinants or Cramer rules. Cramer rules depends on to find delta x, delta y, and delta z, then to divide delta x over delta to find x, and delta y over delta to find y, and finally delta z over delta to find z. So we have here an example using numbers. It will be clear for you. You like numbers. If we have an equation here, 3y plus 2x equals z plus 1, and the second equation will be 3x plus 2z equals 8 minus 5y, and the third equation will be 3z minus 1 equals x minus 2y. Okay, we have here the 3 equations. Okay, and we would like to find out the solution set of these 3 equations. Okay, first we will concentrate about the arrangement. It's very important to arrange to be x first, y second, and z third. So we will put 2x here, okay, plus 3y. We just replace them, but they are in the same side of equal, so we cannot change the sign. Okay, we have here 2x plus 3y, and z we transfer here to be negative z equals 1. Okay, here we are. And second equation, we have 3x first we have negative 5y, we will transfer it to be positive 5y, and we have plus 2z as it is, and we have finally 8. The third equation will be, first we will transfer x to be negative x and transfer y to be plus 2y plus 3z as it is equals 1. Okay, but here it's clear that we need to find out x as positive. The first symbol must be positive to be keep the figure well. Okay, it's in simplest form now. Here we have three equations: 2x, 3y minus 1z, and we have 3x, 5y, 2z, and we have 1x, negative 2y, and negative 3z. Okay, we will have the determinant, which is delta. What's delta? Delta is the coefficients of the three equations, which are 2, 3, negative 1. Okay, we have here 2, 3, negative 1, coefficient of x, y, z, and 3, 5, 2, 3, 5, 2, the coefficients of x, y, and z. And we have here 1, negative 2, negative 3, the coefficients of y, x, y, z of the third equation. And you have already know how to expand this delta. So this delta, if you expand it, you will find the number equals 22. Okay, now we must calculate delta x. Delta x will be the same as this, but we will replace 2, 3, and 1, which are the coefficients of x, y, and z, by the numbers 1, 8, and 1. What 1, 8, and 1? Sorry, negative 1 here. What are 1, 8, and negative 1? They are the absolute terms, which is the right hand side of equal. Here equals 1, equals 8, and equal negative 1. 1, 8, and negative 1, we write them here, and the remainder as it is: 3, 5, negative 2, negative 1, 2, and 3. And you have known how to calculate it. Delta x, if you calculate it, the result will be 66. Finally, we will calculate delta y. Delta y here will be a determinant of third degree, and we will replace y coefficients by what? Yes, excellent pupils or students, answer me that we have 1, 8, negative 1, and the remainder are them: 2, 3, 1, negative 1, 2, and negative 3, and you calculate delta y, the answer will be negative 22. We must calculate now delta z. What is delta z? Delta z is a determinant of third degree also, and we will replace the third column, which is the coefficients of z, by what? By 1, 8, and negative 1. What 1, 8, and negative 1? They are the absolute terms of the right hand side of the equations, and the remainder as it is: 3, 2, 3, 1, 3, 5, negative 2, and the answer will be 44. Now we must calculate x, y, and z. To calculate x, y, and z, we have to divide each of delta x. Delta x here is what? Delta x is 66 divided by delta, which is 22. The answer will be 3. And after that we calculate y. Y, to calculate it, we have to divide delta y, which is negative 22 divided by 22 equals negative 1. Finally, delta z, which is we have divided delta z 44 by delta 22, and the answer will be 2. So now we have x equals 3, y equals negative 1, and z equals 2. And solution set, of course, will be solution set. We write it like that. We have triple numbers, 3, negative 1, and finally 2. So we have solution set equals 3, negative 1, and 2. Okay, my dear students, we will study about the multiplicative inverse. What is multiplicative inverse? We know that if we have 1 over 3, and we know that the multiplicative inverse of 1 over 3 is 3 over 1. Okay, if we have an equation here like that, 2 over 3 x equal 10, and we would like to solve this equation. Of course, we will omit 2 over 3. 2 over 3 multiplied by x, and to find x only, we must multiply by the multiplicative inverse of 2 over 3, which is 3 over 2, and we will multiply it here, 3 over 2 also. So 3 cancelled with 3, okay, 2 cancelled with 2, and x will remain equal 10 times 3 over 2, which is 30 over 2, which is 15. That's a simple equation or simple example about multiplicative inverse of a number. Have we a multiplicative inverse of a matrix? Sometimes. What's the meaning of sometimes? If we have a matrix A, this matrix will be 3, negative 2, 3, and negative 1. Okay. B, okay, we have here B, negative half, negative 3 over 2, 1 and 2, and we will multiply A by B. AB equals, we know that multiplication of the matrices will multiply this row by this column. 3 times negative half plus negative 2 times negative 3 over 2, and the answer will be 4. 3 multiplied 1 plus negative 2 multiplied by 2, and the answer will be negative 2. Okay, my dear students, we have some break for little minutes, and we'll return again. Thank you. Okay, hello my dear students. Again, we will start with multiplicative inverse of a matrix. So concentrate with me. If we have a matrix A like that, this matrix will be 4, negative 2, 3, negative 1, and another matrix B, which was negative half, 1, negative 3 over 2, and 2. And we would like to multiply A by B, AB here. We multiply this row, multiply by this column, 4 times negative half plus negative 2 times negative 3, and the answer will be 1. I'm sorry about the results of the before the break. Okay, if we multiply this row by this column, the answer will be 1. And if we multiply this row again with this column, 4 times 1 plus negative 2 times 2, the answer of course will be 0. And we will multiply this row by this column, 3 times negative half plus negative 1 times negative 3 over 2, the answer will be 0. And to multiply this one by this one, 3 times 1 plus negative 1 times 2, and the answer will be 1. And pay attention for this matrix. This matrix called the unit matrix, which is I. Try to find BA. BA, we will start with B, like that. B here, negative half, 1, negative 3 over 2, 2. And A will be 4, negative 2, 3, and negative 1. And when we multiply them, you will find the answer will be this row multiplies it by column, negative half times 4 plus 1 times 3, the answer will be 1. This row multiplied by this column, negative half times negative 2 plus 1 times negative 1, and the answer will be 0. And we will return again to find the multiplying of this row by this column, negative 3 over 2 times 4 plus 2 times 3, and the answer will be 0. And negative 3 over 2 times negative 2 plus 2 times negative 1, the answer will be 1. And it's I, which is the unit matrix. So we noticed now that this matrix, specifically the two matrices, if we multiply A by B, the answer will be unit matrix. If we multiply B by A, the answer will be the unit matrix. So AB here equal BA equals I, which is the unit matrix. Then we can call A and B are multiplicative inverse of each other. So A is the multiplicative inverse of B, and B is the multiplicative of A, multiplicative inverse of A. If you multiply them, the answer will be the unit matrix. Okay, and my dear students, we can calculate some rules, or we can solve some equations using the inverse matrix. But first, we will have a rule to calculate it. If we have a matrix A like that, A, B, C, and D, okay, and we can calculate its delta. Delta here means the determinant of the matrix A, like that, A, B, C, D. And we will calculate this determinant by times or multiplied AD minus BC. If we have here a number doesn't equal 0, okay, if we have the answer will be number doesn't equal to 0, then this matrix A has a multiplicative inverse. But if the determinant A equals 0, then A here doesn't has the multiplicative inverse. Okay, and we know from the previous example that A multiplied by the inverse of A equals I, which is the unit matrix. Okay, so we will use this to solve some matrices. We have an example here. Okay, we will solve this example. If a matrix, this matrix equals -2, 2, 3, and -4. Okay, and we have delta. We want to calculate the inverse of this matrix, the multiplicative inverse specifically, if exists. We have delta here equal -2, 2, 3, and -4, and we multiply -2 times -4 equals 8, minus 2 times 3 equals 6. So the final answer equal 2. 2 doesn't equal 0. 2 doesn't equal 0 means that A has a multiplicative inverse. To find the multiplicative inverse, A -1 equals 1 over delta. Delta here equals 2 multiplied by a matrix. What is the matrix? It is the matrix A, but we will change something here. Look and concentrate carefully. We will replace these two numbers of the principal diagonal. We will put negative here instead of -2, and put -2 here instead of -4. Finally, we will change this sign. The sign here +2 and the sign here +3. We will put them as -2 and -3. Okay, again look carefully to this rule. If we want to find out A -1, which is the inverse matrix, we will multiply 1 over delta. Delta here is a number which comes from determinant, multiplied by something of a matrix. What is the matrix? If we have the matrix A equal A, B, C, and D, then we will exchange these numbers, D here and A here, and we will change D will be -D and C will be -C. This is the rule. Okay, so to calculate the inverse or multiplicative inverse of A, we put 1 over delta. Delta here is 2, so 1 over 2 multiplied by what? Multiplied by -4, here -2, -2, and -3, and the answer, we can write it here. Half times -4 equals -2, half times -2 equals -1, half times -3 equals -3 over 2, half times -2 equals -1. So we have here the inverse or the multiplicative inverse of A. Here A is -2, 2, 3, and -4, and the multiplicative inverse here is -2, -1, -3 over 2, and -1. And if we multiply them, the answer will be I, which is the unit matrix. Okay, let's move to another example. If we have a matrix like this, if we have a matrix A, B, this matrix is half, 2, 3, and 12, and we would like to find B inverse or multiplicative inverse of B if exists. We have here a test for it. We will calculate its delta. Delta means its determinant. we have half, 2, 3, 12. Half times 12 equals 6 minus 2 times 3 equals 6 also. So the answer equal be 0. Pay attention for that. If we have the delta of this matrix equals 0, so the inverse or the multiplicative inverse of B doesn't exist. It hasn't exist. It hasn't a multiplicative inverse. And we stopped like that. Okay? We have here an example to use this rule. We have a matrix. If the delta of this matrix equals 0, then it hasn't a multiplicative inverse. Okay, we have an example here. The example says that find x, the value of x, if a equal x, 3, 12 and x, and he said that find x by a condition. What's the condition? The condition is that a has no a multiplicative inverse. Yes, we know that if a has no multiplicative inverse, then of course delta, which is the determinant of a, equals 0. So we will write the determinant of a, which is x, 3, 12 and x, and equalize it by 0, because he said that this matrix has no multiplicative inverse. Okay, and we will solve the equation. Here we multiply x by x, and the answer will be x power 2, minus, we will multiply 3 times 12, which is 36, and don't forget to put 0. So we have a simple equation, x power 2 minus 36 equals 0. Okay, and we can solve this equation by transfer this 36 by a positive, and then by using square, x equal positive or negative square root 36. So x now equal positive or negative 6. So the values of x that makes this matrix has no multiplicative inverse is 6 or positive 6 or negative 6. And if he asked me the range or the values of x that makes this matrix has a multiplicative inverse, of course we'll say that are except 6 and negative 6. Any real number put here instead of x will make this matrix has a multiplicative inverse. But 6 or negative 6, if we put them instead of x, the matrix will be has not a multiplicative inverse. Okay, let's move, my dear students, to the next question. We have here solving equations using the rule of existence of multiplicative inverse of a matrix. So we have here a matrix. Say the matrix A equals x minus 1, 4, 3 and x minus 2. Okay, and the request is find x which makes A has no multiplicative inverse. Okay, we know that this A has no multiplicative inverse if the determinant of A, which is x minus 1, 4, 3, x minus 2, has no multiplicative inverse, means equals 0. So we will calculate this determinant by multiplying x minus 1 by x minus 2. If multiply x times x will be x power 2. X times negative 2 equal negative 2x. Negative 1 times x equal negative x. Negative 1 times negative 2 equals 2. And don't forget that we have also 3 times 4. Minus 3 times 4 equal 12. Equals 0. Why equals 0? Because this matrix has no multiplicative inverse. And we will simplify this equation. X power 2 negative 2x plus negative 1x equal negative 3x. 2 minus 12 equal negative 10. Okay. So we must solve this equation. If we use factorization, it will be easy for you. X power 2 factorized as x times x, and negative 10 means negative 5 multiplied by positive 2. Okay, and number times number equals 0 means that x minus 5 equals 0, or x plus 2 equals 0. So x will be equals 5 and x will be equal negative 2. So the values of x that makes this matrix has no multiplicative inverse is 5 and negative 2. But the values which make this this matrix has multiplicative inverse is R except 5 and negative 2. Okay, my dear students, by this equation now we will have the final of our episode now. Thank you very much. Until we meet again next Friday, inshallah, I wish you be happy and study well to succeed. Thank you. Goodbye.